and writing into polar form. Always you can expect one question for writing into polar form. Then see that complex number. If a complex number is written, a complex number, if z is equal to x plus iy, we write x as the real part, y as the imaginary part. Y means part along with I, or we can consider it as the coefficient of I. So here, real part we write Re of z. So Re of z is x, and imaginary part, imaginary of z is y. This we discussed earlier. This is how it write real and imaginary. Now coming to miscellaneous question number 2. See, question number 2, miscellaneous question number 2 is, for any two complex numbers z1 and z2. If two complex numbers are given, z1 and z2, the question is, we need to prove that the real of z1, z2, real of z1, z2, real of z1, z2 is equal to real of z1 into real of z2 into real of z2 minus imaginary of z1 into imaginary of z2. Real of z1, z2 is equal to real of z1 into real of z2 minus imaginary of z1 into imaginary of z2. If you are reading this in a sentence, z1 to z2 means this is z1, z2. We can read it as product of two complex numbers. So real of z1, z2 means, how will you read it? Product of real of product of two complex numbers. So this can be read as real part of product of two complex numbers is product of their real part. Real z1 into z2 means product of their real part minus product of their imaginary part. So the same question can be asked in a different way. Prove that real of or real part of product of two complex numbers is equal to product of their real part minus product of their imaginary part. The idea is same. So here what we do is we take two complex numbers z1. We take it as a plus ib, and other complex number z2 we took it as c plus id. So if we are considering z1 as a plus id, z plus c plus id, now we can write the real of z1. Real part of z1 means real part of z1 is a, and imaginary part of z1 is b. Imaginary part means part with I. So here imaginary part is b, real part is a. Similarly, real part of z2, real part of the second complex number is c, and imaginary part of second number is b. We assume the complex numbers as a plus ib and c plus ib. Now what to prove? Real part of product of these two. So first we will write the product of these two complex numbers. Again, whenever we need to find the real part and imaginary part, you have to write that in standard form. Standard form means first the real part. Real part means what? All those parts without I, they are all real. So real parts together plus then all those parts coming with I, taking I as common, the remaining part. That is called the imaginary part. So first we need real of the product of these two. So we will find the product of z1 and z2. Product of these two complex numbers. After finding product of these two complex numbers, We will write that in standard form, then we write its real part. Then we will do this one. Okay. So, is that answer true? Z1 is A plus ID. Z2 is C plus ID. This is what we are saying. Here also normal multiplication. Normal multiplication means like in algebraic expressions, first we take A, multiply it with each and every term of second bracket. Then take the second term IB, multiply it with everything in second. Taking A, multiplying with C, AC. Again taking A, multiplying with IB plus I am writing first I into AB. We multiplied A with all of these two. Now what? Now multiply IB. One of you asked me which chapter we are doing. That's very funny question. Which chapter we are doing? Okay, so now AC, A into ID is IAD. Then taking IB, multiplying with C, it is I into BC plus IB into ID. I into ID is I squared BD. This can be further simplified. AC plus, see, these two terms are having I. In all complex numbers, group all those terms with I together. That is, by taking this common factor I, what is left out? AD plus BC. We know the value of I squared. We learned it. I squared is minus 1. So if this I squared is minus 1, this becomes minus BD. Z1, Z2. Now this complex number we write in standard form. Standard form means first the real parts together, then plus I into the remaining part is called the imaginary part, the parts with I. So how many terms are there without I? They are all coming in real part. So which all terms are there without I? AC is there. So this AC minus BD in one bracket. And in fact, that is the real part. Is it? Because there is no I. This is the real part. Plus I into AD plus BC. We wrote this product of complex numbers into standard form. Standard form means x plus iy form. X plus iy means first real part plus imaginary part. Imaginary part is along with I. So here, what is the real part of Z1, Z2? This is the product of two complex numbers is again a complex number. In this complex number, what is the real part? Real part means all those terms without I. This is AC minus AB. Now, A means what? See, from this one, we know A is the real of Z1. So AC, A is the real part of Z1 into C. What about C? C is the real part of Z2. Real of Z2. So product of AC. A multiplied by C is nothing. That is a product of real part of Z1 and real part of Z2. Minus B. B, what is B? B is imaginary of Z1. Imaginary of Z1 into imaginary of Z2. Proof. That is what we need to prove. So see that real of Z2 is equal to real is equal to real Z2 minus imaginary Z1 to minus Z2. This question, as I said, it can be asked in a different wording with the different wordings. Prove that real of product of two complex numbers. The real of product of two complex numbers is product of their real part Product of generated part minus product of here we have here the question is to prove the product of real part of product of two complex numbers. Same thing with a slight change, it can be asked like that. The slight change is instead of proving the real part of Z1 Z2, they can ask prove the imaginary part of Z1 Z2. If it is imaginary part of Z1 Z2, see that which is the imaginary part. This is the imaginary part. This part. This is the imaginary part. So the question can be prove that imaginary of Z1 Z2 is equal to A. What is A? A is real of Z1 T is into imaginary of Z2. Instead of real of Z1, real of Z2, it will be real of Z1 into imaginary of Z2 plus B. Real of Z2 into imaginary of Z1. Imaginary of Z1 into real of Z2. This way. That question also can be asked. So the idea is it is slightly deviated from this question, right? Okay, now coming to question number 3. 3 is a homework. Question number 3 you have to do. If you are not getting, do let me know. Fully direct simplification. Simplify, take LCM, simplify. Standard form means first real part, then imaginary part. Anyway, it's parts. Simplification. Later on also we have few questions for simplification. While doing that question, you will get more idea. Now, before starting question number 4, write a knot. Knot. See this one. I think it's an interesting one. Write knot. With a star. Knot. Let Z is equal to A plus IB. Z is a write not. Let Z is equal to A plus IB. You know what's the meaning of Z bar? If Z is A plus IB, Z bar is called it's what? It's conjugate. And so Z bar denote the conjugate of Z. And how do we write the conjugate? Conjugate means what? Conjugate means the complex number which differ in the sign of their imaginary part. Sign of the imaginary part. That means A, the sign minus IB. Z bar is A minus IB. Now, see that if we multiply a complex number with its conjugate, we will see what happens. If a complex number and its conjugate is multiplied, you can observe it A plus IB into A minus IB. A plus IB into A minus IB resembles with an identity. Which identity? X plus y into x minus y, which is x square minus y square. So this becomes A square minus I square B square. A square minus B square. Some of you wrote it. A square minus I square B square. Now, what is I square? I square is minus 1. We know that I square is minus 1. Then minus I square will be plus 1. So we get it as A square plus B square. We got Z bar as A square plus B square. But we know that if Z is equal to A plus IB, then what is the meaning of this one? Modulus Z. The meaning of modulus Z is the root of A square plus B square. This is what modulus of Z. In definition, in the beginning we learned it, modulus of z. So if z bar is root of a square plus b square. Root of a square plus b square is z bar. Modulus. So z bar is modulus z square. This one actually you have to remember this. This is how we are getting it. Z bar is in doing few questions, we make use of this property. You can take it as a property, Z bar, or a complex number multiplied by its conjugate will give the square of its modulus. In words we can say this: a complex number multiplied by its conjugate, or product of a complex number and its conjugate gives what? Square of the modulus. Modulus its square of modulus. Make it out of it. I hope you have done it. Now let me take the attendance. I'll take the attendance and come back to group. The next question, that is question number 4. Question number 4. See these types of questions. Remember these types of questions. If x minus I1, x minus I1 is given as root of a minus ib by c minus id. Keep it as equation number 1. X minus I1 is given as a minus ib into c minus id. The question is to prove that. X square plus y square the whole square. X square plus y square the whole square is a square plus b square by c square plus d square. This is what we need to do. It is in your miscellaneous chapter 5, page number 112, question number 4. Question number 4 of the miscellaneous. See, remember such questions. In all these types of questions, here, what is given? X minus Iy is given. What we need to prove? We need to prove something related to x square plus y square. In that note, we wrote it. If a plus ib is known, if a plus ib is known, a plus ib into a minus ib. That is what we wrote just now. A plus ib into a minus ib will give a square plus b square. So naturally, x minus iy multiplied with x plus iy will give x square plus y square. Then we can square. Now, so in all such questions, whenever a plus ib or a minus ib, one of this is given, or in terms of x plus iy and x minus iy, if one of this is given, and in the question, if they are mentioning about x square plus y square, or in this question, if they mention about a square plus b square, in all such questions, what you do is write if a plus ib is given, then write a minus ib, then multiplying we get a square plus b square. So here, x minus iy is given, then write x plus ib. Again, see, writing x plus iy, we will make a loophole, and easily we don't mention it as conjugate, because conjugate of a complex number means we have to write in real part and imaginary part, then only change in sign in imaginary part. They are called conjugates, complex conjugates. So here, instead of mentioning it as conjugate, because in this one, to write the conjugate of this one, first of all we have to write that into standard form. And writing the standard form is not that easy one. So here, the easy shortcut, what we do is we will replacing minus I with I. Means wherever minus I is written, or I with minus, that I with minus, that is more standard. Replacing I with minus I. Wherever I is there, right minus, that means change the sign of I, that's all. Replacing I with minus I. Yes, minus. This I, if you are writing it as minus I, minus becomes plus. In fact, change the sign of I, that's all. Wherever I is there, put minus I. Wherever minus I is there, put I. So we change I into minus I. So x plus I y is equal to root of a changing plus id by c plus id. Equation number 2. X plus iy is given. Replace I with minus I. Wherever I is there, change the sign. Minus I. Now, our aim is to get x square plus y square. We have seen that in the previous note. If x minus iy and x plus iy are known, to get x square minus y square, what to do? Multiply these two. So 1 into 2 gives equation number 1 and 2. If you are multiplying, left hand side is x minus iy into x plus iy. Right hand side is root of a minus ib by c minus id multiplied with a plus ib by c plus id. Left hand side, x minus y, x plus y form. X square minus y square. So this will be x square minus I square y square. Root a root b is root of a. Root of a. Again, a minus ib into a plus ib is a square minus I square b square by c square minus I square b square is c square minus I square b square. We multiply in both sides. We use the identity x plus y into x minus y. That's x plus y into x minus y. What is I square? What is I square? I is minus 1 people. If I square is minus 1, this becomes x square plus y square, because I square is minus 1. Then minus I square will be plus 1. X square plus y square is root of a square plus b square by c square plus b square. Why? Because I square is minus 1. Yes. So where you got the idea? You're right. Now come to the question. What to prove? We need to prove x square plus y square the whole square. We got x square plus y square only. So how to get this one? Squaring both sides. Squaring. Left hand side becomes x square plus y square the whole square. Right hand side square root. If you are squaring it, the root sign will go a square plus b square by c square plus d square. Prove. So in all such questions, remember it, if a plus ib or a minus ib is given, or x plus iy or x minus iy, if one of it is given, and in the question, if it is x square plus y square or a square plus b square or their modulus, then definitely the better way is even to find modulus also. This is one of the way. Z bar. Multiply this, conjugates, we get square of modulus. Now we will do question number 11, which is same time. Then we'll come back to question number 5. After doing question number 11, we'll come back. See question number 11. Question number 11. Write the question. Question number 11. See, question number 11 is A plus IB is, question number 11, A plus IB is given as x plus I the whole square, x plus I the whole square by 2x square plus 1. 2x square plus 1, equation number 1. What to prove? What is one of this? Anyway, that s square plus b square. Prove that s square plus b square is x square plus 1 the whole square, x square plus 1 the whole square by 2x square plus 1 the whole square. This is what we prove. A square plus b square is x square plus 1 the whole square by 2x square plus 1 the whole square. See, this question also resembles with the previous question. Same thing. Here, yes, exactly same. Because here also a plus ib is given. A plus ib is given. We need to find a square plus b square. Change something in a square plus b square. If x plus iy is given, to find x square plus y square, replacing I with minus I, then multiply. Exactly same thing. Proceed. Replacing I with minus I. Replacing I with minus I. See, we are not using the word conjugate because conjugate is a different meaning. So replacing I with minus I, we get a minus ib. A minus ib is x minus I. Wherever I is there, in the given expression, wherever I is there, change I as minus I. That's all. X minus I by x minus I the whole square by 2x square plus next equation number 2. And we know that we have seen that if a plus ib and a minus ib are known, to get a square plus b square, what you do? Multiply these two. 1 into 2 gives 1 into 2 gives a plus ib into a minus ib. Right hand side x plus I the whole square by 2x square plus 1 multiplied with x minus I the whole square by 2x square plus 1. Is it? A plus ib into a minus ib is a square minus I square b square. Product of two fractions. How to multiply two fractions? Multiply numerator into numerator, denominator to denominator. Multiplying a square into b square. A square b square is ab the whole square. So this is x plus I into x minus I square of it, the whole square. We have taken the square common, divided by this one. 2x square plus 1 multiplied with 2x square plus 1 is 2x square plus 1 the whole square. Square of 2x. If any quantity is multiplied by itself, we call it as the square of that number. So 2x square plus 1 multiplied with 2x square plus 1 is 2x square plus 1 the whole square. Now this is the left hand side. In the textbook is Hamza. Textbook, anything? Okay, few textbooks, few questions, there are printing mistakes in few questions. Anyway, this is the correct question. X square plus 1. This is if you have changed in textbook, if you have changed any of the signs or terms, correct it. This is the correct question. Now, yes, minus I square is, so this becomes a square plus b square. A square plus b square. Because I square is minus 1. Again, x plus I into x minus I is x square minus I square whole square by 2x square plus 1 the whole square. That is a square plus b square. You see, again, I square is minus 1. We know it. So this is x square. I square is minus 1. So minus of minus 1 becomes plus 1. The whole square by 2x square plus 1 the whole square. That is what we need to prove. So see that in these two questions, it is same thing only, same idea. So remember it, whenever a plus ib or a minus ib, x plus iy or x minus iy, p plus I cube, p minus I cube, one of it is given. To find p square plus q square, or in the case of this one, a square plus b square, or x square plus y square. This is the easy way. Replace I with minus I, we get those conjugate in left hand side, multiply it, we get the answer. Coming to question number 5. Question number 5 is most important. Definitely question number 5 is similar question. Question number 5, changing the numbers. One question is almost sure in your all examinations. Question number 5. It is slightly lengthy activities. Two questions combined together. The question is to write the polar form of 1 plus 7. I used to write polar form. Question number 5. X plus iy is equal to 1 plus 7i by 2 minus I the whole square. See that to write in polar form, x plus iy is common. Then we need to write the value of x, then y. After finding x and y, then r root of x square plus y square, cos theta, sin theta, etc. But here, in writing polar form, first thing is we need to write the given complex number in standard form. Then only we can write x and y separately. Here, x is the real part. This one, it is not in standard form. So whenever a complex number is not given in standard form, for any simplification, first we need to change the standard form. That means to separate real and imaginary part. So how to simplify? Numerator cannot be simplified. 1 plus 7i remains as it is. 1 plus 7i. But denominator, 2 minus I the whole square. A minus b the whole square. We know the expansion. A minus b the whole square is a square. A square is 2 square. 4 minus 2ab. 2ab will become 2 into 2. 4i. 2ab is 4i. Plus b square is I square. Again, how to simplify it further? We know the value of I square. I square is minus 1. So write the value of I square. Numerator, nothing can be done. Denominator 4 minus 4i minus 1. Again, it's not a, we can 4 minus 1. We can further simplify it. 1 plus 7i by 4 minus 1 is 3 minus 4i. Again, it is not in simplified form. Is it? How to simplify it further? Whenever we get a complex number denominator or any expression with I, multiply by the conjugate. Always like rationalization. Rationalization you learn in lower class exactly same. If you are multiplying by the conjugate, 1 plus 7i by 3 minus 4i multiplied with what's the conjugate of this one? 3 plus 4i. 3 plus 4i. Now, numerator, expansion like normal expansion. It is like normal expansion. Normal expansion means Take 1, multiplying with these two, then take 7i, multiplying with these two. Taking 1 and multiplying into 3 plus 4i, 1 into 3, 3, 1 into 4i, 4i, 1, multiplied with 3 and 4i, plus 7i multiplied with 3. 7 3s are 21i, plus 7i, 4i. 7 4s are 28. I into I is I squared. Denominator of the form x minus y, x plus y. Always x squared. That is 3 squared. 9 minus 4 squared is 16 I squared. A plus b into a minus b. Zero. So we just received circular regarding summer holidays. You now here, you cannot, don't write it directly. Don't write one of your mean can be write directly 3 square plus. No. Write I square, then next step only because you are learning it this year. I square, the value of I square you are starting. So show that. So this becomes now 3 numerator 3 4i plus 21i is plus 25i. I square is minus 1. So 28 I square means minus 28 divided by 9. I square is minus 1. So 9 minus 16 becomes plus 16 because I square is minus 1. You replace I square is minus 1. So here sign changes here and sign changes here also because wherever I square comes, sign is the opposite. So this is x plus I by 3 minus 28 is minus 25 plus 25i by 25. That is x plus I by is. This one we know how to write in standard form. How will you write it? Real part separate, imaginary part separate. Yes, correct. Some of you wrote the answer. Minus 25 by 25 is minus 1 plus I. Write real part first and imaginary part second. It is not over. We wrote the given complex number in standard form. That's all. We wrote the given complex number in standard form. What is our given complex number? X plus I by is minus 1 plus I. Now the question is to write this into polar form. How to write into polar form? We write x is minus 1, y is 1. Then r stand for root of x squared plus y squared, root of minus 1 squared. That is root 2. Polar form, you learn. Be very familiar with polar form. Polar form is a sure question for 4 marks. And the same question came for 4 marks a number of times. In examination, at most, instead of 2 plus I, 2 minus I in denominator, 2 plus I they can give. Instead of writing this one, they can give reciprocal. Only numbers will be changed. The idea is same. After finding out, directly we can write cos theta and sin theta. Use the formula cos theta is x by r. So cos theta, x is minus 1, r is root 2. Sin theta is y by r. Sin theta is 1 by root 2. Previously we wrote r into cos theta plus I sin theta. No problem. Even if you are not writing directly, if you are writing the formula cos theta is x by r, sin theta is y by r. No problem. Directly you can write it. Cos theta is x by r, sin theta is y by r. Yes, Umair, what's your problem? Any problem? Women Zakaria? Problem number 64, Women Zakaria, any problem? Cos theta and sin theta. Now, to find the amplitude, what is it in quadrant 1? Start doing it in quadrant 1. In quadrant 1, cos alpha, we write. While writing cos alpha, we write only the positive value. So it is 1 by root 2. In quadrant 1, we take the positive value. Now think it, cos of which angle gives 1 by root 2. That you write in radian measure. Cos of which angle? Cos 45. So instead of 45, we use pi by 4. 1 by root 2. Cos pi by 4 is 1 by root 2. Therefore, alpha is pi by 4. We got alpha. Now, to check our amplitude, the argument we suggested two methods. One method is see the sign of x and y coordinates, taking it as a coordinate, or taking sign of sine and cos. One of it, anyone. So I prefer x, y. X is negative, y is positive. Negative, positive. See, x is in the given question, x is negative, y is positive. So negative and positive. X think it's x negative, y positive in which quadrant? X negative, x is negative. That means left side, y is positive means above. So in quadrant 2. In quadrant 2. Now in quadrant 2, we know the formula. In quadrant 2, our theta is pi minus alpha. That is pi minus pi by 4, which is 3 pi by 4. So we got r is equal to root 2. Argument z is 3 pi by 4. Therefore, our x plus iy r into cos theta plus I sine. This is called the polar form. And our x plus iy is minus 1 plus I. R is root 2 cos 3 pi by 4 plus I sine 3 pi by 4. This question is important, very important. So you have to do it. You have to practice it. Similar questions with change in numbers can be asked. With change in numbers. Remaining will be same. The idea will be same. Numbers can be changed. Now it's second part. Second part I will do few simplification. We will do 1 plus 3i by 1 minus 2i. 1 plus 3i by 1 minus 2i. Again, what to do? Multiply by the conjugate. All of you started, do it fast. 1 plus 3i, 1 minus 2i, multiplied with conjugate of denominator is 1 plus 2i, 1 plus 2i. Multiply. All of you multiply. Taking 1, multiplying 1 plus 2i, 1 into 1 and 1 into i. 1 multiplied. Now, plus taking 3i into 1. 3 is 3i. 3 into 6i square by 1 minus 2i, 1 plus 2i. A minus b, a plus b, a square minus b square. So 1 square minus 1 minus 4i square. Is it? 1 square minus 2 square is 4i square. This is 1 plus 2i plus 3i is 5i minus 6. 1 plus 4. Reason I square is minus 1. 1 minus 6 is minus 5 plus 5i by 5. What do we get? X plus iy is equal to, if you are separating it, minus 1 plus I, remaining you know. It is the previous question only, but leaves a space, you have to complete it. Leaves a space, you have to complete it. So same thing. Now see that. So if you are getting a complex number as a fraction, what you do is multiplying by the conjugate, we can write it in standard form. Now see that question number 3. Question number 3, it is same thing only. Second factor, 3 minus 4i by 5 plus I. Multiply by the conjugate, you will get a number. Similarly, in the first bracket also take LCM and simplify. Multiply it, simplify it, you will get the answer. Question number 3, same. Now, 6, 7, 8, 9 also homework. 6, 7, 8, 9. Miscellaneous questions. All those questions in miscellaneous which are easy and which you have done before in exercises. Those are all homework. See, solving equations you learned last year in class 10. Same thing we did 5.3 also. Same thing. Do those as homework. All questions are very easy. Try it as homework. We will come to question number 10 and stop. Question number 10. Question number 10. Start doing question number 10. What is your again cube textbook? Question number 10 is also something printed wrongly in cube textbook. This is the question. If Z1 is 2 minus I, Z2 another complex number 1 plus I. These two complex numbers are given. The question is to find the modulus of Z1 plus Z2 plus 1 by Z1 minus Z2 plus 1. In few textbook it is something plus and minus sign is different, I think. Anyway, this is the correct question. This is the correct question. The question is to find the modulus of this one. It's very easy. Before finding the modulus, first we will find this complex number in standard form. So numerator, we will simplify numerator and denominator separately. Z1 plus Z2 plus 1. Simplify Z1. Just put the values. Value of Z1 is 2 minus I. Value of Z2 is 1 plus I plus 1. What did you get? What will you get? Minus I plus I cancel. 2 plus 1, 3 plus 1. It is 4. Is it? So numerator, simplified separate, that's better. Numerator is 4. Now denominator. Denominator is Z1 minus Z2 plus 1. Z1 is 2 minus I minus Z2. Minus Z2 means minus 1 minus I. Both are negative. Minus Z2 means minus of. I skip one step. Minus of 1 plus I means minus 1 minus I. So this is Z1 minus Z2. Now plus 1. Simplifying, what do we get? Minus 1 plus 1 cancels. Minus 7 6. 2 minus 2i. Now our chain Z1 plus Z2 plus 1, Z1 minus Z2 plus 1 becomes 4 by 2 minus 2i. That is 4 and 5. If you take 2 out, 1 minus I, this cancels. We got it as 2 by 1 minus I. Is it? Again, see that to find the modulus of any complex number, first we have to write the standard form. Whenever we are getting such an expression, how to write in standard form? Multiply by the conjugate. That is 2, 1 minus I. Multiplied with 1 plus I, 1 plus I. Numerator 2 into 1 plus I. Denominator is 1 minus I square. Again, you know the value of I square. What did you get? 2 into 1 plus I by 1 plus 1, because I square is minus 1. So we got Z1 plus Z2 we got Z1 plus Z2 plus 1, Z1 minus Z2 plus 1 as, what do you get? Simplifying 2 into 1 plus I by 2 to cancel. We got it as 1 plus I. So it is 1 plus I. What is the question? The question is it to find this one? No. The question is to find what? If a complex number z is equal to a plus ib, how will you find the modulus of it? The modulus of this one is nothing. It is root of a square plus b square. You know this definition. So this complex number is 1 plus I. Our aim is to find the modulus of it. Z1 plus Z2 plus 1. So modulus of this one means modulus of 1 plus I. And how will you find modulus of a plus ib? Is it 0? Modulus of a plus ib is root of 1 square plus 1 square. Root of a plus ib, 1 plus I. Modulus of a plus ib. Modulus of a plus ib is root of a square plus b. So modulus of 1 plus I is root of 1 square plus 1 square, which is root 2. Root 2 is the answer. That's it. So question number 3, 6, 7, 8, 9, homework. We did up to question number 10, 11 also we did. Any doubts, anything related to today's class? So next class tomorrow, I think we can complete this complex numbers. Any doubts? Yes. I will wait. You said to wait. Yes, it's no problem. What is it, Ammar? You wrote a number. Is it something related to? Ammar, you wrote a number. Is that related to something? Yes, class is over. I'm waiting for a few students. I'm waiting for few people to complete because few people said that they didn't complete it. So I'm waiting for those who have completed, they can leave. No problem. Those who have completed, they can leave. I'm waiting for few people to do it. I think all of you have completed. Is there anyone to complete? No. So see you in next class.